Welcome back, ladies and gentlemen, to the last video in our Unit 1 of AP Chemistry. This is Lesson 1.8. We're going to be focusing on valence electrons and ionic compounds. I'm just going to be perfectly honest here. This may be the shortest video I actually ever make in terms of at least this series, because the concepts that were related to this are not that difficult to figure out, considering you do know the basics of ionic bonding and how compounds are formed already. Hopefully. If not, we'll discuss that a little bit and then discuss some of the concepts that are related to different types of bonding over this video. So take a few minutes. If you like it, feel free to like, subscribe if you want to see more. I plan on publishing one of these for every topic in AP Chemistry. Hopefully, if I've got time. I'm a busy person. Anyways. So what's the whole goal of this video is for students to be able to understand and explain the relationship between trends in reactivity of elements and the periodic table. And the long story short with this is that elements that are from the same groups on the periodic table are going to form compounds in similar whole number ratios and by default have similar physical and chemical properties. It's a pretty basic concept to understand. So for example, compounds like NaCl and KCl and LiCl, they're all going to have very similar chemical properties because they A, combine together in a 1-to-1 whole number ratio, B, they're ionically bonded, and C, well, because I said so. No, just kidding. But let's go through some of the essential knowledge just real quick. It says the likelihood that two elements will form a chemical bond is determined by the interactions between the valence electrons and the nuclei of the elements. Basically what this means is that we need to take a look at the charges that are produced based off of the group numbers that are on the periodic table. Again, that's based off the number of valence electrons either gained or lost in order to form ions. The ions have charges, they form attractions with one another, and as a result, we get an ionic bond and a chemical compound. Elements in the same column of periodic tables tend to form analogous compounds. That is, when I pick two elements that are from the same groups on the periodic table, I end up with compounds that are very similar to one another. Charges of ionic compounds are governed by their location on the periodic table and number of valence electrons. All that means is that ionic compounds and their charges are based off of periodic table location, such as in this particular chart right here. The periodic table location indicates the charge that are present on the ions when forming an ionic compound. This is a predictable periodic trend. Everything in that first group has one valence electron, and when it forms an ion, it loses that electron, and so therefore has one fewer electron than protons and takes a positive charge. Similarly, in the second group, they lose two electrons, so you form a 2+ charge because you have two more protons than electrons in their structure. Skip the transition metals because that's where things get a little dicey. And then you end up in group 13 with a 3+ charge. Skip the carbon group, 3 minus 2 minus 1 minus 0. The reason why they're minus on the opposite end of the periodic table is that these do not lose electrons, rather they gain them, so they have more electrons than protons and take a negative charge. And because of the crossing and dropping technique that you're probably very familiar with forming ionic compounds, and if you're not, check out one of my nomenclature videos. One of the big reasons I don't discuss nomenclature, interestingly enough, is it's not really an AP chemistry concept. Is it helpful to know nomenclature? Absolutely, and know those concepts. However, it is not necessary per se based off of the information in the essential guide or the course guide, course description of AP chemistry. And because of crossing and dropping, similar compounds in terms of the number of atoms in the compound. So for example, as I mentioned before, lithium and fluoride, it is a 1+, 1- charge, so the compound that's formed is LiF. NaF will form in the same 1-to-1 ratio, Kf, same 1-to-1 ratio. You get Mg and O, again 1-to-1 ratio, Ca and O, 1-to-1 ratio. Take a look at their charges, they cancel one another. If I look at Mg and Cl, it's going to be MgCl2, cross and drop those charges, so it'll be MgCl2, MgBr2, etc. So basically what I'm saying here is that elements that are from the same groups are going to form ions and ionic compounds in the same whole number ratio. MgCl2, MgBr2, MgI2, SrCl2, SrBr2, SrI2, etc. And you can see that in the next slide here, because if we look at an example of group 2 and group 7 here, that is the alkali metal group and the halogen group, CaCl2, 2+ charge, 1- charge, they form in the same whole number ratio. So as you see here in the examples, all of those alkali earth metals react with chloride the exact same way in a 1-to-2 whole number ratio. When I switch things up a little bit and keep the alkali earth metal the same and change the halogen same whole number ratios. So all we're trying to understand here is that elements that are from the same groups are going to form ionic compounds in the same whole number ratios, and as a result, they're going to share similar chemical and physical properties. So if I take a look at this quick question right here, it says that CIS is a commonly found ionic compound. Which compound would have the most similar chemical properties? You have CS2, MgO, CaCl2, and none of these. If we look at where the elements are located in the compound Ca and S, we notice that Ca is located in the second group on the periodic table, so that's going to eliminate CS2 because C is located in the 14th group on the periodic table. So we're looking for elements that form compounds A in the same whole number ratios and B are from the same groups on the periodic table. And the only one that applies to this is answer choice B, MgO, because Mg is from the same group as calcium and O is from the same group as sulfur. CaCl2 is an ionic compound, but it forms ions and forms its compound in a 1:2 ratio, where we're looking for something that just forms in a 1:1 ratio here. Again, that's all this video is about. So really hope you enjoyed that. Again, very, very short, very brief, very straightforward, very to the point. If you liked it, feel free to subscribe. I've got some other videos on this channel that I think you like, and we'll see you very, very soon in the next one. Bye-bye, everybody.